presenters of the day, Teemu, Määttänen and Jokke, Heikkilä. And they're going to present their working process and some notions about when they've been developing digital tools for next spring's DVD study module, which is in collaboration with Aalto University and Theatre Academy. So please.
Thank you, Tomi.
Thank you. Hello.
He's Teemu.
And he's Jokke. And as said, we are responsible for this development of these digital tools.
And I could maybe a little bit elaborate. I think we're going to also give a quick, or not that quick look also for the history, how this DVD, which is short for digital visual design, how this whole thing has come to be what it is now. So.
Yeah.
And
actually,
why?
It's here. So this presentation is divided into kind of like a three-part thing. So the first part, we are going to just tell you a little bit about the DVD or digital visual design module, so you get this general idea what it is. And the second part is the past project, or the kind of like the first cycle of the DVD that we did some development for, and then we are going to talk about the upcoming plans and development and ideas what we are planning to do. Digital visual design, there's the address uniarts.fi/teac/dvd. This module is focused on digital visual design and is aimed at lighting, sound, and scenography students. And the aim of the module is to introduce and examine interaction, participation, and immersive space through technology. It's here. So the study module focuses on digital visual design and performance. And these theory, methodology, and practice of the field are the key concepts, and the concepts of interaction, participation, and mediated experience and immersive space provide a mutual theoretical and practical ground which relate to the discussions and assignments in the course. So the objectives of the DVD module is that the students will acquire advanced knowledge on the practices and theories of digital visual media production for performance, and the students will develop sophisticated technical and artistic skills for the production of digital visual media for performance, and the students will develop the ability to critically evaluate theoretical and practical questions within the field of visual media and performance. So key issues here are kind of like the practice of doing and developing skills and then critically evaluating your work. The module is 25 credits and it's one term with 52, I've counted the days, so it's 52 full days of working. So here you can see the distribution of the days, how much everything is presented. So there's four days of just kind of like introduction theory. Then there's digital visual media course, which is in the coming course Unity Basics. We will talk about them a little bit later. And there's camera work in performing with visual media, and interactivity and playful design course, which is interaction with the Unity and virtual reality for 8 days. And then there's a final production for, or this kind of like demonstration production for 20 days. The tools that we are talking about here today mostly comprise of the courses digital visual media, interactivity and playful design, and the last piece, which is the mediated performance course. And the performing with visual media will use ready-made tools that we are not going to talk about here. The history of the development of interactive tools and techniques of interaction with the computer in the context of performance arts for the divided module goes back a few years. There's been this course taught by me and Mikael Eriksson called Interactive Technologies in VES from, I think, from 2009-ish. And it was a course that went through a few iterations in terms of the technology and also the ideas of what we were looking for. And it was kind of like this testing ground and search field for interaction and what it meant to light design and scenography and sound design students. It started out as this kind of like more lo-fi human-computer interaction course with physical sensors and buttons and some Max MSP classes and coding. And then it moved towards these kind of like air-based or camera tracking systems like the Kinect. There were a few reasons for us wanting to develop the technologies and techniques being used for interactive studies. First, we felt that Max MSP was a little hard to learn for the students in the short period of time we had, so that it took a lot of energy and focus away from examining actual interactivity in practice. As Joris brilliantly demonstrated, it was exactly like that. So most of the time was used using the computer and not actually doing and exploring interactivity.
Yeah, maybe quick note here that in our basic BA program, for example, there's only one little course about programming in general, and that's it. So these MI courses, we have to expect, and which is usually the case, that the people coming there might have no programming background. So that's the where we start.
Yeah. Also, the sensors got more complex when moving towards these air-based or camera-based systems like the Kinect. And there was a need for a simplified tool designed specifically for these courses in mind. And the design processes that light designers and scenographers and sound designers have. The idea was to develop these tools so that they would be easy to get running and get more a straight path towards testing these interactive ideas and situations on the stage. So easy to learn, simple on the stage, and quick testing. We started with the idea that we would mainly use the Kinect as our sensor when developing this divided course, but leave the system open in such a way that other sensors and machines could be later added. Also, an important starting idea was the space and the spatialization of the video image or the virtual world. We wanted to have a really simple two-projector, two-screen setup. One screen behind the performers and one on the floor beneath their feet. On those screens, we wanted to have some kind of objects that would be rendered in real time and that you could interact with. In addition to real-time renders, we wanted to have some image layers to add pre-rendered images and videos. For sound, we designed some trigger systems that send out triggers from the real-time visuals. For example, collisions and position and velocity. So Kinects, space, projectors, images, sound. important issues. We did a little bit of research on the internet of tools that, or if there were tools ready-made, trying to find software that would be simple to learn, but that still could have enough variety to produce a wide array of different interactive outcomes. We tested the eMotion software developed and used by the French artists Adrien M. and Claire B. But the lack of documentation made it a little hard for us to comprehend. The software also had a lot of features that we really did not need, but needed something a little bit more simpler. It also at the time, a couple of years ago,
This was 2015.
it was
spring.
was still available, but now it has been discontinued, and it was kind of
The
like
signs were there already that is going away.
Yes, it was kind of like on the brink of extinction, and now I think you can still download it from some sites, but from their site there's no sign of it anymore. And I do have the understanding that they might be still using it in their own work. So here's an example of their pixel performance probably made with the tool.
Yeah.
And this was a clear inspiration for us to kind of like take some of these ideas that this tool offered and try to build a little bit more simpler tool that would still result in these kinds of
Yeah, we totally copied this idea of this projection.
Yeah. Stole it.
Stole it, totally.
Yeah. The courses for the DVD module were taken from the existing curriculum of the departments of Light and Sound Design and Scenography, with the exception of the new course Performing with Visual Media that was added to the module to address the use of live and recorded video in performance. This meant that all the courses had their own histories as well as an array of different tools. One of the ideas behind the whole DVD module was that it would walk through some of the ways media is being used in performing arts. The idea was that after taking the DVD module, the student would understand that there are many different paths to using technology in a performance and a variety of theories and many ways to build interactivity between a performer, the audience, and technology. The diversity of these courses all around was maybe the most distinctive feature of the first cycle of DVD in 2016 or 15, 16 probably. And the pilot before it, the mediated performance course in 2015. When looking at the 5 courses that are here divided by the content being taught, the core, or being divided by the subject of the studies, we actually get 9 separate courses with 7 different sets of technological solutions.
And there was kind of thin layer between these, so there was some ideological layer or connection between these, but I don't. In reality, it was something that wasn't really good.
There is a lot of different technological things to learn in quite short periods of time. So we have After Effects, we had Hypnotizer media servers, we had camera work, we had the Kinect, we had the Leap Motion, we had the Mayo, we had the VDMX, we had Ableton Live, all technologies, particle systems, augmented reality. Let's go. Let's go again.
Let's look it again.
So there was this huge pile of technologies and things to learn, and clearly for the students, it could have been a little bit less maybe. The technologies were perhaps a little all over the place as well. if you look at them from the perspective of interactivity, but still quite well in line with the technologies used in the field of performing arts. A good example of this is the After Effects and Hypnotizer course that was designed for light design students and is a basic and valued course on the use of media on the stage. However, in hindsight, as the whole module started to shift more towards interaction through technology, the use of these more traditional and timeline-based technologies became harder to integrate into the interaction design workflow. So here are some of the, or actually all of, kind of like a demonstration of all of the tools that we ended up developing.
For the 2016 round.
For the 15, 16
15 and 16, yeah.
Rounds. First, there's a short demo of the tools, what they do. And then there's a demonstration of me using the tools. And then there's the demonstration of the students using the tools. So the first tool we developed was this box 2D particle system. Is it running? Yes, awesome. And this was made in processing using the box 2D library. And with this, we developed this Kinect, really simple Kinect tool. I will show it in a second. It was developed with the simple OpenNI library. The basic functions of the box 2D tool are placing rectangular shapes on two separate windows, as you can see here, with individual controls for the shape's attributes like size, friction bounds, and color. And you can kill off all the particles at once, or the last created, or the upper or the lower window. And these demos are kind of like structured now in a way that we use the same structure to teach this tool to the students. So we gave an assignment after each of these short videos. So the first assignment was to make a little performance by using this mouse interaction to place objects on screens and move them about and have people on the stage interacting with those. You will see them in a bit. But yeah, that's about it.
Very famous physics, the Box 2D physics engine thing that's running behind this is from the what bird is it? Angry Bird.
Yeah, Angry Bird uses the same library for physics. So, yeah. And here's another video. Is it running? Here we go. So the next assignment was that you can use gravity on the screens individually. So both screens have their own gravity systems, and you can control them.
And we really tried to emphasize that thing when the students did these simple exercises or assignments, that they would find the interaction between this person or persons on stage and whatever is produced by these. They had to find some sort of a evident interaction ways.
Yeah. And then you can set ID numbers for the particles and send out collision data. Is it running? No? No, it's running. So send out collision data of the particles through OSC to, for example, Ableton Live for synced sounds. And there are three types of collisions sent out, which are particle to particle, particle to boundaries, which are the screen boundaries, and particle to kinematic particle, which I will talk about the kinematic particles in a bit. And here you can see just a visual demonstration of the collision, that when the particles collide, they will turn red and at the same time send out messages out into the internet. No, not the internet, but Ethernet. Yeah. And create chaos. And then there's this is just a quick demo of the really simple, just a tool to get the Kinect running and sending out basically all of the joint and user data of the Kinect into OSC. So this is kind of like a router just for the Kinect. And in Box 2D, you can see the Kinect data coming in. You can use the joint data to place these kinematic particles on the positions of the joints, and you can use the lower screen to do a floor projection so that it has the kind of like the virtual camera placed on top of the performer. The kinematic particles can be used to interact with the shapes placed in the Box 2D world. It should come up. So there's only one Kinect, but you can generate this kind of like from the top image from the data. It's just fun to see yourself moving as kinematic particles.
And you crashed.
Yeah, that's my position, to use the computer. And my working space is really small, so I had a little bit of trouble actually hitting the particles because this area to move was like this small. So, but yeah, you get the idea. And you can use the Nintendo Wiimote, which is kind of like a
game remote, gaming
type of really simple remote through oscillator with the Box 2D tool. So any parameter of the Wiimote can be controlled, or any parameter from the Box 2D tool can be controlled with Wiimote, as well as data coming from the simple Kinect tool. So any slider that you can see, you can assign to be controlled from these data sets.
So here you are pushing one button on the remote and it starts creating those particles from your hand.
Yeah. So here the particles are coming from my left hand, and then there's another button set down there to kill the particles, so I can control it from the stage. Way. The last video of this tool is setting the Wiimote data to the yaw parameter of the Wiimote data to control the hue of the immediate particles. So I can create this awesome rainbow colorish world.
More is more.
In addition to these video demos, the particle system has the following features. We have an image texture input through Siphon as a particle's texture, as a snapshot image from the birth or as a live stream. We have a Siphon input as background image, and then we have attractor force for each Kinect joint position. And then we built this really generic OSC router to take in data from the user as a slider or as mouse or Wiimote buttons or orientation and acceleration or the Kinect or the Mayo or the leap motion. And this incoming data can be changed to OSC messages and scaled and made kind of like this generic data sent out by the router to be used in other programs like the VDMX. and you can monitor the incoming data as well.
This was a separate standalone program.
So here you can see that we have the monitor for example, Wiimote. And you can see the incoming data. So you can monitor stuff happening. For example, Kinect has a lot of data coming in, so it's a good thing to have some place to see what kind of stuff you have coming in. And here's a video of the leap motion tool, which is just routing this small sensor data that recognizes your hands and the bones in your hands and sends out that data. It also has this grid trigger system and built-in recorder. Like that. And then we used also the Myo, which is like a gesture-based sensor on your arm.
Yeah, it senses your muscle, actually
Yes.
the electricity, you know.
Yeah, and it has
EMG, I think, is the
gyroscope, so you can get the orientations of your arm and use that. A little bit like the Wiimote, but more precise. So we built a tool for just to get it running quickly, just connect and go.
Because the idea for this course, because this was for the interactive course, is that we will present quite wide variety of different kind of sensors, Kinect, Leap, vMotion, Myo. And then we have some sort of a centralized tool, which was at the beginning one, the router. And you can, you know, as a performer or designer there, choose, okay, this data, this will, you know, work for this thing, and I will route this to the Ableton Live or some VDMX or Max MSP for some further processing, or to create some sort of auditive or visual content.
Yeah. And have an experience that because there's many more sensors in the world besides these, but as a student have a understanding that there are different kinds, and I can plug them in and see what they do and make them do stuff. So that was the idea, to just make that process a little bit more easier. And here's a demo of me testing the Box 2D and the simple Kinect tool in EdLab space in 2015.
Hey, it follows you.
Just kind of like seeing all of the different playing, basically, yes, with the tool. And it's basically, this is just a toy. We were talking about earlier about the playfulness and games, and we were talking with Jokke that with this video, at least the idea is how to use a kind of like this rigid, really simple thing that actually does not so many things. It's kind of a really simple tool, or not even a tool, a toy. How can you use it in a playful way and still have this kind of interesting output or something, some looseness or messiness of playfulness being produced? And here's a short video of the students playing with the toy.
The short demos.
Siinä on varmaan äänikin jo.
Onko?
On, mutta ei mulla ole kyllä kytketty. And here are some still images. We didn't have videos of all of these demos, but there's of course always the demo, how many particles can I put until it crashes? A lot. But it did crash, like with one particle as well. So. And here the group is using the remote and microphones. The idea here was to fool the Kinect to think that there is this person there, but and the ways that you could maybe fool the Kinect to think that this is a person.
Jokainen meistä tuntuu tosi hyvältä, kilahtaisi tyhmä ja tiiviimmäksi.
Yes, that was it. So that was the first run and these tools. Now we are in the process of planning and developing for the next cycle of DiviD, set to start with the introduction theory course in January of next year, so a few weeks away. For this cycle, we took a hard look at what we did previously and if we managed to reach the goals that we set for ourselves, or if the goals actually were specific enough. Quite quickly we came to the conclusion that we needed to rethink the whole module. We wanted to change the focus from showcasing the many aspects of technology in mediated performance to a tighter focus on playfulness, gaming and interactivity. We wanted to have these themes present in all of the courses of DiviD from different viewpoints, like from art theory, game design, live camera work, virtual and augmented reality and media art. We also wanted to unify the technology being used throughout the module. We hope that this will enable a deeper level of learning. The hope is that we are not just teaching a technology that will be obsolete in a year or two, but rather the skills in design of playful interaction and virtual worlds that can adapt to different technologies.
Yeah, I could comment actually there on something that Joris also touched on, that one, I think a big problem by developing special tools for courses is that the accessibility for that tool is kind of gone unless it's really solid standalone program, which those programs weren't so simple that you download and click play or click open and that's it, because they required all kind of libraries and setups and things in order to work. So whenever the course was over, if somebody was interested, wanted to continue learning or developing stuff by themselves, the tools really weren't there. So the accessibility wasn't really at all there after the course. I think that was at least one thing that I've been thinking also, that we need to also look for some other solutions.
Yes. Well, one solution to that would be make them take it and go for it.
But then we end up with the situation that the maintainability, who maintains and the workload are there, and it's not feasible actually.
Yes. We wanted to continue using these camera-based tracking systems for their transparent nature, but wanted to extend the tracking area and also the accuracy. We also figured that we needed to guide the focus of the students more towards spatial and interactive questions. To achieve this, we decided to mainly track objects or individual trackers rather than sets of trackers or performers like in skeletal or anatomical tracking. The point is to get the focus from performing in the virtual space to interacting with the virtual space. Also, if we have a system that has freestanding trackers, it's possible to build these more complex skeletal systems later on. When we started to plan for the next round early this year, HTC had just come out with the freestanding Vive tracker. Do you have it here somewhere? It's a puck, which we thought would be a good solution for our needs.
Yeah, this actually came because we were first looking into getting a more fine-tuned motion capture suites, because nowadays you can get, it's something like 1,500 to 2,000 euros. You can get really good mocap suites, and we were trying out of those about a year ago or less. But then we actually came quite quickly to a realization that this is not what we want, because motion capture is actually quite easily just motion capture. It's just, we're just replicating the movements. And we realized, no, that's not fulfilling the goals we have, to get the space in, to be a part of the performance, the part of the game, the part of the whole thing. And with this, we realized that these are really easy to, whatever we have on stage, you can just plug it there, and now it became part of something that can be incorporated into our system, so to speak.
The camera-based or air-based systems usually lead to this kind of interaction, so that I'm interacting with, I'm doing stuff, but I'm not actually touching anything, or it's hard to, if we have a virtual space that I'm in, and I'm being tracked in, for example, in this, even these kind of high-tech motion capture systems, and I have a cube in the virtual space here, there's no way of me knowing where it is, even though it's there, but I can't really touch it or do anything, because I'm being tracked. But the object in the virtual space it's not here. So with these pucks, our idea is that we can activate real objects that are being modeled, like Joris actually was talking about the same thing with the fancy demo. But you can model like this chair and put a tracker on it and calibrate so that they actually match in the virtual and the real world. So we don't actually need to track me at all in order for me to interact with the virtual world, because I can interact with this. I'm interacting, hey, there's interaction going on. So I can build these more natural ways of interacting instead of this, which is still kind of cool. And we can do it by attaching this, for example, here, and we're in the same, air-based thing. So this system for us seems right now we haven't started the course, so we'll come back
and
to
ask
it.
about half a year.
Yeah.
How did it go?
But this is kind of like the lo-fi. This is not too expensive. These are
That's about 90 euros, 100 euros.
100 euros per puck. So this is the lo-fi version, and we have access to the Roihupelto Virtual Studio, right? That's the of Aalto University, and they have this, I think, motion analysis system or something.
Yeah,
I don't know which one is it, but they have this motion capture suit thing. But they can also track objects there, so we can have this kind of like high-end $1 million facility to test more accurate, because it's like, I don't know what
it's actually super accurate also.
It's
That's
also
like a
really
1
accurate.
millimeter.
Yeah.
But the thing with a real camera base with that motion analysis is the space.
Yes.
Because with that you can track bigger than this space.
Yeah, it's like 10 or 12 meters or
Yeah.
something, that it's like millimeter accurate. And this you can use to up to
the square about
4 or
5 meters. What's the halkaisia?
Yeah, but it's still quite a big space that you can use this.
Yeah.
So this and the high-end system are sort of like compatible in our thoughts at the moment.
Yeah,
We'll see how
as a
we'll
way
tell.
to track, to get outside input
Yes.
into our system, which is Unity.
Yes. So as the kind of like a management software for all of this interaction and input, we chose the Unity game engine, as we wanted to expand the aspects of gaming and playfulness in the design process. And there's a lot of good reasons for choosing Unity. For example, it offers us tools to create game logic. You can build interactive virtual environments in 3 dimensions, and you can use these HTC pucks and also the HTC headset systems for virtual immersion. It's also free, and there are a lot of free courses to learn it. It can be expanded through scripting, and there's an active community, and it is very well documented and easy to learn if you want to learn it more deeply.
Should I show quickly,
Yes.
just show you context what is it, because it's a game engine, and it's used to build commercial games from very small, like simple 2D platform games to much more complex gaming applications, all up to, this is, for example, this is also real-time rendering. This is not pre-rendered stuff, to very high quality stuff. And since it is gaming engine, as Teemu said, it allows us to build, because the gaming is something that came very early on as the main focus, the main word, the main umbrella for this next round, the game design, and approach this whole thing through play and game. And it will allow us to, first of all, teach. It's a graphical based in its core. Of course, there is a textual programming, but we're going to skip all that. We're going to use only, GUI style interaction with this program to build game logic, so that, for example, here it's just super simple now. I just made for this idea that I have this 3D world. I have, put boxes there, and I just threw up a character, which is now I'm controlling with these arrow keys. So this character could be following this, or it could not be. It wouldn't have to be a character, it's some other thing. But I can build logic in this 3D world that can be, replicated somehow in the physical world. And when it goes around there, it can interact things can happen. They can happen in the game world. We can take views from there and project. So we can have audio or visual content from that we project, or we can take the, let's say, controlling data, and we can use light or sound to control it, light or sound in the physical space also, and yeah, start building with this really simple. Oh, sound, but it's not here. Really simple interaction logics. And the one thing that we have to remember, which I said earlier, that we have only 2-3 weeks with the Unity for the students. And we really carefully have to try to find the path that we enable, we give enough, we show enough, we give enough information that they can start building meaningful logic systems in order to get out the playfulness of the play in this system. So they can, in the first part when we just learn this tool, so when we go to the next part, when we really incorporate the stage also, so they could, start finding stuff. What happens, when you incorporate the states happening and with the logic here. And let me show, here's something. Oh yeah, this was this one. In the notion of more is more, here's I'm controlling this guy, and there's a few hundred boxes or 1,000 boxes, and we could, of course, we could have this happening also on states, and the game would be, or the idea was to find the box with the clue, and you would go around with the puck and try to find the correct box. Maybe, I don't know, just a naive idea there. But anyways, yeah, this is the platform that we've chosen now for the upcoming dividend part. Yeah, basically that.
Let's see if this comes back. Bloop. Bloop. Yes. And we are, as Jokke said, we are trying to streamline the workflow in Unity with these HTC systems and the VR systems, so that it would better suit the needs of a play or a performance and not just game design. Still, we do want to introduce some aspects of game design into the workflow. The idea is not just to take a technology and try to put it into a play or performance, but to have a practical starting point for the work coming from another discipline, in this case, game design. From game design, we mostly use the concepts of interaction, rules, and goals that are implemented through this Unity game engine. At the same time as we are moving towards these more complex and high-tech systems, the sensory systems become more transparent. The focus shifts from how this is done towards what is happening and towards the design of actions, events, and worlds. As a result of choosing the Unity game engine, which is quite a large piece of software, we have developed much less tools by ourselves. As the Unity community is quite large, a lot of smaller tools can be found as add-ons from the Unity Assets Store. Jokke has, however, developed some scripts for Unity that we plan to use. For example, a script to get or send out data from Unity to other programs through OSC. We are planning on using the Node Canvas editor, which is a visual Max MSP type node-based scripting tool.
UScript.
What was it?
UScript. Unity script is the name of the tool.
Yeah. Instead of teaching C# scripting, which is the Unity script language. we hope that the students that go through the whole DVD module will have at the end a good understanding of the possibilities of virtual worlds in the context of performing arts. To ensure that the students would have sufficient technical skills, we have trimmed the technical courses to include only Unity and VR courses. There is also a longer production at the end of the module for more in-depth artistic work utilizing these tools. So from this, we move to this, which looks a lot cleaner now and has a lot less. Remember all the stuff that was in there now. So now we only have Unity and trackers, basically, for technological things. And here's a last video. This is me and Jokke with this. I think it was not these, but
what tracker anyway? Yeah.
Two trackers, and we are controlling these puppets that have this algorithm that they try to walk when they are being pulled, and they do this because they have a point where they
want to
put their hands to. So we made this kind of modern dance piece in 2 seconds.
No, 32 seconds.
Yeah. The idea here is to kind of like have a little bit more complex things, but kind of like these toys inside of Unity that you can take and play with and explore what do these do, and they produce these complex things. And you can have groups even though you have only like one tracker, so you don't need the whole suit to actually make these performers in the thing. Yeah, that's it. 7 minutes for.
Yeah, I could actually maybe add here just some closing thoughts about this coming period and with the Unity and the challenges that personally at least I'm seeing or I can anticipate is that because of the limited amount of time and sort of a complex tools anyways, is that how to get over the joy and excitement of the fun and the perseverance with programming. Even it's not, we try to make it simple, the programming, but to try out things and to tune in what happened there. Oh yeah, this happened there. Okay, this was interesting. Let's maybe try this thing and get the loop happening, the iteration loop. That I think Joris also kind of referenced that it's really important to do things, try, play, get excited about it, and change and do it again and iterate, and then and also do this in groups so we can also verbalize and discuss out what happened there, what things emerged. One thing is this emerging emergent things that start happen there when you start incorporating logic. And okay, we won't have that much time that we could get AI or algorithmic stuff here. But anyways, at least with these rule-based things, what things emerges that we didn't think when we designed this, and to be tuned into observe those when we try this and develop and iterate more and more.
It's a challenge to somehow balance the technology and the coding and still have time to play.
And
that's what we're trying to now maybe more find and not so much develop, but to find these tools that offer that kind of playfulness, that are kind of nice toys, and do have I actually like the wow effect. I think it's a good effect, and it's kind of a basic, for me at least, it's a basic effect. If it's not just a technology wow, but I do get the wow effect from plays or from art. And it's a good feeling that, what is that? That's the moment that should happen more, and we should appreciate it, and not just not bring it down because it's a wow effect. It's a good thing. It's a reaction, so we should grasp it, and with those toys, they kind of operate in that wow effect territory.
Yeah.
Yeah.
Something like that.
Okay, thank you, Teemu and Jokke.
Kiitos.
Thanks.
Okay, do you have like direct questions to Teemu and Jokke, and we can slowly coming to the summit part, but we can start if you have like directly some questions to them.
What I really like about your 2D tool is that it translates really well to surfaces in a physical space. And now you're generating a virtual volume that you need to somehow connect to the spatial space. So I was very curious how you're going to do that with projection.
We don't necessarily need to do 3D, so Unity can do 2D. So basically we can do the exact same thing with the particle systems in Unity as we did with the Box D2D tool. So it's possible to kind of like just place two cameras into the virtual world and use one for floor and one for the background, and then flat it out so that it doesn't have the Z dimension at all. And yeah, and you're kind of set for the same kind of thing.
Especially the performing artists, they really love to be physically playing, right? So
Yes,
it's good to connect it to the physical floor, and
Yes,
physical space.
definitely. We have kind of two solutions for the immersion into the virtual space. So one is to use the POX and this projection system from the same projection system with two projectors, and calibrate it so that the objects that are being tracked in this projection as well. And the other one is with the goggles, so that you are in the space but can actually touch stuff and move stuff. So those are the kind of like probably the two sets that we are going to build, that we have for the students to explore and to try out.
And we don't have to also, we can use the 3D set, and we don't have to map it one-to-one in the physical space, because we could, we can use it that, for example, just in the projector visualizing setup, that we have something, we have a view from projector view from top on a real space, but we don't project everything that we have in our virtual world. Maybe just some things that are relevant to our game or whatever performance we have, and then we can use these anyways, just maybe as a triggers to start things. Then, and we have these like 16 of these, can be happening or interacting at the same time in the same space. We can use them differently. Everything doesn't have to be one-to-one linked in a visualizing sense. So we can pick and choose also what we are going to do.
You can just skip the projection and skip the virtual kind of 3D world altogether, and just use the tracking system to track objects, to build interaction between the objects and the space. So that you have these triggers and you know where the objects are. You can tell the system that, okay, if I bring this here, now this will happen. If I bring this here, this will happen. But it doesn't have to be mapped.
Yeah, but just example
onto the
hook this on performers and develop the logic in the Unity, that whenever these whatever performer I'm in the trigger sense representing, when these two are in contact, when this is happening there and that is happening there, do this or that's new, and that doesn't have to have any visualizing at the same time here. So
it kind of goes back to the lo-fi trigger, like with sensors, for example, like just buttons. that you have buttons on stage with wires, but now we can have them in
Yeah, and we can.
a little bit more.
And
high-tech
here comes the
version of
game
that.
design part. You know, the game design, the game logic, and whatever. Because we are trying to approach this through game. As you said, game design. We're going to have a game designer, professional, you know, here to teach us game design. In and he will start in physical, board games, and we're probably going to move there to do those board games on a virtual. I mean, the physical space also, in a virtual with these tools. Yeah.
But it is a question. To answer your question, it is a question. Kalle.
I just want to add a little bit to that. There's a really good video on YouTube by Harvey Moon. It's called Real-Time Projection Mapping with HTC Vive. So you can actually use the HTC Vive pod or the controller
Yeah, you can
to control your
Yes.
projections, so you can have like 3D objects on the stage. So that's also something I'm looking forward to trying on the course. Maybe if I go there, because there's not enough space for me. So we'll see.
Yes. Yeah. That's one.
You have to buy a bigger computer.
There's like multitude of ways that this technology and these systems can be used. But it basically boils down to what we have ready-made, because things like that take a little bit of time to develop. Yeah.
Okay, let's give an applause and go for the discussion part.